There is tremendous pressure on engineering educators to prepare graduates for the complexities of 21st century workplaces. While our curricula require attention to holistic student development, we've also seen an increasing shift to a more holistic and scholarly approach to supporting engineering educators. One dilemma is that engineering or STEM academics often experience such professional development programs as generic. What we're going to be talking about today is an approach within an engineering faculty to engineering staff academic development that can be described as a community of practice approach. Now, we're a contact-based residential research-intensive institution in South Africa, and our faculty has been actively engaged in a range of program renewal initiatives over a number of years. Last year, in the face of COVID-era online teaching, we actively started to look at all these initiatives using a number of pedagogical models because we wanted to understand how we could better help our lecturers to bridge the divide between educational theory and classroom practice. In other words, how do we help the development of the scholarship of teaching and learning? Our first step was to classify all the engineering education initiatives for the past 5 years using our overarching theoretical tool, the CAS model. Now, this is about our mandate to provide cognitive, affective, and systemic support for a holistic curriculum and learning experience. We identified 25 case studies where academics are using effective systems to enable improved cognitive grasp. Now, in all these case studies, staff were linking disciplinary theory to applied practice in their own subject areas, connecting the dots between the why, what, and how of learning in a cumulative manner. And we call this a semantic wave. We're going to start by showing you how 3 different lecturers make those connections between theory and practice in their classrooms using the semantic wave.
Our first case study is a first-year chemistry course for all engineering disciplines with around 1,000 students. There isn't time to revise the chemistry fundamentals, so a group of lecturers has developed a randomized online quiz bank. The activity was designed to be a low-stakes formative assessment, allowing the students to retake the test in order to improve their marks and, of course, to learn. Questions in the database are designed to allow the students to surf down the wave, pulling through the conceptual through to the contextual through a set of progressive questions. Questions range from pure science, foundational, conceptual, or theory-based questions that may be somewhat abstract to the student, and move into the application of theoretical concepts in scenarios where there's a clear formulaic or mathematical procedure that can be applied. Finally, the students move to questions with less clearly defined answers, but that are contextually familiar to them, where they would be required to use some sort of engineering judgment. In our second case study, we start at the bottom of the wave with a flipped classroom case study assignment for a second-year material science course for mechanical, mechatronic, and industrial engineering students. The challenge in this syllabus is to avoid siloed learning in the face of the broad and dense syllabus. Lecturers use a case study of failure analysis in order to pull various theoretical concepts and procedural analysis techniques together in a real-world application. Again, this is designed as a low-stakes assessment in the form of a reading assignment, a walkthrough video that directs students back to the textbook chapters to help them connect the dots, and a multiple attempts online comprehension quiz with formative feedback between the attempts in order for students to check that they are getting it. The student is taken on a job shadow journey with a consulting engineer, climbing back up the wave by starting with a contextual real-world engineering problem. A vehicle wheel axis has failed and you as an engineer need to determine why. Various material and mechanical tests are used in order to determine the material and mechanical properties of the axle, and then the properties are linked back to the expected behavior from a theoretical perspective. The student is then guided into interpreting the results in order to determine the reason for failure. Now we look at moving up and down the wave, integrating concepts and applications and contextual situations. In this case study, a third-year transport engineering course for civil engineers is used. Students are assigned a road design project where they work in small groups to find an appropriate local site where they can apply road elevation concepts to create a particular road design. This case study is designed to use elements of experiential learning, peer engagement, and teamwork to simulate a real-world engineering application, including tasking them with the use of software and translating technical information into a readable report. The students snakeboard up and down the wave to integrate the know, be, do elements of learning engineering. They start with the conceptual and look for a contextual scenario where the concepts can be applied. Then they apply the analysis and design principles and procedures to create their solution, and integrate these elements into a final design report where they have to use the road design software. So each of these case studies illustrate how the engineering educators themselves are bridging theory and practice divides in their subject areas. But each of these case studies is also supported by a particular educational theory, such as unpacking threshold concepts to support epistemic access, or self-regulated learning through the flipped classroom approach, or using pedagogies of engagement and experiential learning to build professional identity. If we look at these initiatives collectively, we can see that they too can be located on the semantic wave. They demonstrate the active bridging of educational theory and practice in the engineering education context. They provide examples of contextualization of the scholarship of teaching and learning, and through sharing these examples with their peers over a variety of platforms, they enable epistemic access and cumulative learning, from core pedagogical concepts through applied classroom initiatives into contextual applications of learning opportunities across all the engineering disciplines. Ultimately, they supported the establishment of a sustained community of practice. We can see that this project has enabled reflective teachers to develop a scholarly approach to their teaching while enacting the institutional vision of creating an engaging learning environment that supports student success.
Although many of these initiatives have been written up and published in formal journals and conference proceedings, practical accessibility is a very important feature of our approach. Most of the initiatives have been captured over the past few years as posters or case study videos. Now, these resources are available on a dedicated shared faculty website. Collectively, they represent practice-based examples of engineering education strategies underpinned by educational theories, and they're created by engineering academics themselves for engineering academics in our Global South context. The case studies and initiatives are supported through teaching and learning mentorship and funding for things like student assistance, equipment, and other resources. The faculty hosts annual workshops, teaching mornings, and a teaching forum where these case studies are shared and developed. Staff feedback indicates that exposure to the educational theories has enriched their practice. They speak of engaging with accessible methods and tools to understand student learning, and explicitly refer to the collaborative community of practice approach as supporting the development of their scholarship of teaching and learning. We believe that such a developmental community of practice approach enables engineering academics to take ownership of their teaching roles and to strengthen their sense of identity and belonging in their profession. And isn't this exactly what we want for our students and graduates? The ability to effectively draw on their professional knowledge in practice.